Hello geometry students of mine. In this video we're going to talk about our 1.7 notes. We're going to talk about three-dimensional figures. So let's go ahead and get started. So let's first define the three-dimensional shapes that we'll be talking about. We're going to be talking about polyhedrons, and a polyhedron is a solid with all flat surfaces that enclose a single region of space. So that space that we're talking about is three-dimensional space, 3D. All right, so the flat surfaces that form the polyhedron, an example would be right here. It's kind of hard to tell. This arrow, hold on, this arrow right here is pointing at a flat face on the side. Those flat surfaces are called faces. So let's go ahead and label that. Okay, it's a face. Now, the intersection of two faces, like right here that this arrow is pointing at, the intersection of two faces is called an edge. So if you would label that. And then where three or more edges intersect, they'll intersect in a point, and each of those points is called I'm going to kind of change my arrow here, it's called a vertex. Okay, so the two kinds of polyhedrons that we will be studying will be prisms and pyramids. So let's talk about what makes a prism a prism. Well, first of all, a prism will always have two parallel congruent faces. Okay, this prism that we're given as an example here, those two parallel congruent faces, that would be the one on the top and the one on the bottom, trying to shade those in, are polygons. Those polygons happen to be pentagons. So we have two of them and they're congruent and parallel. And then the faces of the polyhedron will be parallelograms. Okay, usually if we have what we're called a right polyhedron where all angles are right angles, those parallelograms will be rectangles. Okay, so two congruent parallel faces called bases, and then the faces of the polyhedron of the prism, will always be parallelograms. Usually they're going to be rectangles. Okay, so then let's talk about what makes a pyramid a pyramid. Well, a pyramid is going to have, a prism had two bases, a pyramid is only going to have one base, okay? So it's going to have a polygonal base, that base will be a polygon, and then three or more triangular faces. So in this example, you can see that our base happens to be some kind of a rectangle, some kind of a parallelogram or rectangle, and then notice that all the faces are triangular. Okay, so that's the difference between a prism and a pyramid. All right, then what 3D shapes are we going to study that are not polyhedrons? Well, one would be a cylinder, okay? A cylinder, you'll notice, has two bases. Those bases are circles, and then the face is just this continuous curved surface, okay? So that's why it's not a polyhedron, because the face of the face, I guess you could call it one face, of the cylinder is not made up of polygons, okay? A cylinder has two bases, but a cone is only going to have one base. So a cone is a solid with a circular base connected by a curved surface to a single vertex. So just one base, and then you'll have a single vertex. Okay, and then we'll also be talking about spheres in this course. A sphere is a set of all points in space, in three-dimensional space, that are the same distance from a given point. A sphere has no faces, edges, or vertices. Now, if we were to take this phrase out in space, if we were to take that out and just talk about a flat surface and all the points that are the same distance from a given point, we would be talking about a circle. But if we can go ahead and talk about three-dimensional space, then all the points that are the same distance from a given point called the center would form a sphere. Okay, and then how do we name polyhedrons? Well, we name them by the shape of their bases, all right? So here we have a triangular prism. Now here's a prism that isn't, the prism does not necessarily need to be sitting on its base. So the bases are going to be these two, I'm going to try and shade in these two red triangles. There's two of them, they are congruent and they are parallel. So those are the bases of this prism. This prism just happens to be sitting on one of its faces. You'll notice that the faces are rectangles. Okay, so since the bases of this shape are triangular, we call this a triangular prism. This is a rectangular prism because the bases are rectangles. Now the thing about rectangular prisms is you can really, doesn't matter, we can call the bases, in this case we can call the bases the top and the bottom could be the bases, okay? Or the bases of this rectangular prism could be the left side and the right side, or even the front and the back. So a rectangular prism, you just need to pick two congruent parallel bases and call those the bases, and the other rectangles would be called the faces. All right, and then this next example, it's a prism because I see 1, 2 congruent parallel faces. Since those congruent parallel faces, the bases are pentagons, we call it a pentagonal prism. Okay, and then the next three examples are pyramids. You'll notice that they each only have one base. The base of the first one is a triangle, so we call this a triangular pyramid. The base of the second one is a rectangle, so we call it a rectangular pyramid. And the base of this third example is a pentagon, so we call it a pentagonal pyramid. All right, and then we're also going to be talking about regular polyhedron. Regular polyhedron, okay, a regular polyhedron, all of its faces are regular congruent polygons. Okay, all of its faces are regular congruent polygons, and all of the edges are congruent as well. Okay, there are only 5 regular polygons called platonic solids. Platonic solids. Okay, they're listed below. We have a tetrahedron, which has 4 equilateral triangular faces, a hexahedron, or more commonly known as a cube, that has 6 square faces. We have an octahedron that has 8 equilateral triangular faces, a dodecahedron, which has 12 regular pentagonal faces, and then an icosahedron, which has 20 equilateral triangular faces. So those are the regular polyhedrons. Okay. We're going to look at an example. Now, this example is not in your notes, so if you could just follow along. But this is something that you'll need to be able to identify when you are looking at polyhedrons. We need to be able to determine whether each solid is a polyhedron, then identify the solid. So say yes or no if it is a polyhedron, identify what the name of it would be, and then if it is a polyhedron, name the bases, the faces, the edges, and the vertices. So let's just run through these examples really quick. This first one, yes, it is. The solid is formed by polygonal faces. So it is a polyhedron. There are 2 congruent parallel rectangular bases, so we would call it a rectangular prism. Okay, let's see if we can name those bases. Well, the authors, as they looked at this, they let the bases be M-O-N-P. Let's see. Or I'm sorry, M-N-O-P. I said that wrong. So M-N-O-P, so the bottom, what it's resting on, is one of the bases. And then the other one is parallelogram R-S-T-Q. So those are the bases, okay? And then the top and the bottom are bases. So then we have 6 faces. And here's the list of the 6 faces. Those would be all those parallelograms that are not bases. The edges, there are a total of 12 edges, okay, listed here. Vertices, there would be 8 vertices. Edges, notice, are all line segments, so when we name edges, we use the proper way to name a segment. The vertices are all points. There are 8 of them, and remember we use capital letters to name the points. Okay, and then the next example is not a polyhedron because it has a curved surface. So it has 2 congruent regular bases, so it's called a cylinder. It's not one of our polyhedrons. All right, and then one more example. Here, let me slide it up so we can see it a little bit better. Okay, is this a polyhedron? Yes, it is. The solid is formed by polygonal faces, so it is a polyhedron. The base is a triangle, and the three faces meet in a vertex, so it is called a triangular pyramid. All right, and then let's name the base. The base is a triangle. It would be triangle ABC. Okay. Let's next name the faces. And the faces are all triangles. They're listed here. There are, well, the authors looks like they called the base, they repeated it as one of the faces, and then the other three triangles are the other faces. Okay. The edges, there are 6 of them. Remember, when you name an edge, you're going to call it a line segment. And then the vertices, there are 4 of them. They are points, so we call them capital A, B, C, and D. Okay, and the next thing we're going to talk about is how to find surface area and volume of these three-dimensional figures. So I'll let you take some time to study this chart. Again, I think most of this is review for you. Just a couple things I want to remind you of. When we're talking about surface area and volume, surface area would be the total surface area of all the faces added together, and we always measure surface area with square units, okay? And then volume, we're talking about how much space, how much three-dimensional space is enclosed by these shapes, and we measure volume with cubic units. Couple other things I want you to be aware of are some variables. Remember, capital S will be total surface area, capital V will be volume, capital P will always represent the perimeter of the base, so the distance around the outside of a base, and then capital B will always represent the area of the base. Okay, so make sure you have those in mind. So we're going to do a couple work a couple of examples of finding surface area and volume. Now, these examples are not included on your note sheet, so if you want to grab a piece of scratch paper and work these along with me, you can. But let's look at this first one. First of all, we need to note that we're looking at a square pyramid, so I should have included that in the directions, that this is a square pyramid. We're going to find its surface area and we're going to find its volume. So let's start with surface area, and the formula for surface area for a pyramid, if you look at your chart, its surface area is 1/2 capital P times L plus capital B. Let's make sure we know what all those things stand for. Capital P is the perimeter of the base, okay? L is the slant height, okay, not to be confused with the regular height of the pyramid, but the slant height. And then capital B is the area of the base. Okay, so let's fill in and work this out. That would be 1/2 times the perimeter of the base. Remember, the base is a square and each side measures 6, so that would be 4 times 6, which is 24. Perimeter of the base is 24. Okay, times the slant height. Remember, the slant height is this measure right here. The slant height will be perpendicular to an edge of the base, and regular height will be perpendicular to the base itself. So our slant height, we are told, is 5. And then we're going to add to that capital B. Capital B is the area of the base. Now remember, the base is a square, and you find the area of the square by taking the side of the square and squaring that. So that would be plus 6 squared, and then we'll do the arithmetic. Let's see, that's 60 plus 36, so 96. Now this is surface area, so we measure surface area in square units, so 96 square centimeters. Okay, so that's how we find surface area. Now, to find volume, again, you can look back at the chart. The formula for the volume of a pyramid is 1/3 capital B times H, where capital B, remember, is the area of the base, and this time H isn't the slant height, H is the regular height. All right, so to find the volume, we will take 1/3 times the area of the base. Well, the base is a square. We find its area by squaring the edge, and then we're going to multiply that by the height. The height is 4. So 1/3 of 36 is 12, and 12 times 4 is 48. So 48, and since this is volume, this is going to be cubic centimeters. Okay, let's work another example. This time we're going to find surface area and volume of a cylinder. Okay, so again, you can refer to your chart to get the formulas. To find surface area of a cylinder, we're going to take 2 pi r, which is 2 pi r would be the circumference of the base, okay? And then we're going to multiply that by the height. Think of a soup can. If you were going to take a soup can out of your cupboard and take the label off and open it up, that soup can is going to be a rectangle, okay? Where the length of the soup can label would be actually the perimeter, not the perimeter, excuse me, the circumference of that base. So 2 pi r. So we'll take 2 pi r, that's the length of that rectangular if you think of a soup label, and then multiply that by the height. So we're going to multiply that by h. So that'll give us the surface area, but then, I mean, well, that's called the lateral area, but then remember we also have a top and a bottom, okay? And those are circles. You find the area of one of those bases by taking pi r squared, but then we'll double that. Okay, so now filling in some numbers, we'd have 2 times pi. The radius is 6. The height of the cylinder is going to be the distance from one base to another. So that's going to be times 18. And then plus 2 times pi times that radius squared is 6 squared. So let's do a little bit of arithmetic. 2 times 6 is 12, and 12 times 18 is 216. So this would be 216 pi. Plus 2 times 36 is 72 pi, and then we'll add those together. Our final answer is going to be 288 pi. This is surface area, so this would be in feet squared, okay? And then to find the volume of a cylinder, you take the area of the base is always a circle, so that would be pi r squared, and then multiply it by its height. So that would be pi times, the radius is 6, so pi times 6 squared, and then times the height. The height is 18. 36 times 18 is 648. I worked that out earlier, so 648 pi. And then since this is volume, it would be feet cubed. Okay, so now if you want to take a look at the bottom of your note sheet, you'll see your homework for page 71 listed there. You can get started on that now and get a head start, but we will have some time to work on it in class when I see you next. And if you have any questions about either the notes or the homework, be sure and ask me then.